Alrighty, our next video here is going to be solving multi-step equations. So if you remember from last time, we were solving single-step equations, which meant it only required one manipulation or one application of the golden rule, doing something to both sides of the equation in order to get the variable by itself. In these equations, we're going to have to do more than one step, but the process will be pretty much the same as what we were doing before, just multiple times. So first vocab word, multi-step equation. What is it? This is any equation that takes more than one step to solve, so the name is very descriptive there, so write that down. Okay, a lot of problems are going to involve consecutive integers, so this is just a good vocab to throw in here. It'll become useful throughout the rest of this year. Consecutive integers are any integers in counting order. For example, 4, 5, 6. They could even be negative, so it could be like -2, -1, 0. Just remember that if they're negative, if they're in consecutive order, they're getting less negative, so to speak. Okay, consecutive integers in a row. Number theory, that's the next one. Number theory is just kind of a broad topic. It's just the study of numbers and the relationships between them. So a lot of times people will mention number theory. We won't use it in particular in this class in problems necessarily, but it's good to just know that if someone mentions that, what they're talking about. It's the study of numbers and the relationships between them. So pretty much all of your math classes are dealing indirectly with number theory. You learn equations or formulas or things like this. Those are all the study of numbers and the relationships between them. Okay, a couple more vocabs. Nope, that was it for this section. So next up, problem solving tips. When we're solving multi-step equations, we have to work in reverse, and this becomes very, very critical. Well, technically, we just have to follow the golden rule, but the easiest way to do that is to work in reverse PEMDAS. So you go backwards step by step by step, and the best way to do it is by example. So I'll jump straight to those in just a second. Last thing I'll mention before doing the examples is when we multiply both sides of an equation by something, it's absolutely important that we remember to put parentheses around whatever we're multiplying to both sides so that we don't forget and leave a piece off. Okay, that will come into play in some of the examples. Let's just get on to some examples. First one, here we go. 3x plus 5. If you were to follow PEMDAS and you look at the variable here, the first thing happening to it is it's being multiplied by 3, and the second thing that's happening is it's having 5 added. So when you work backwards, you want to do those in reverse. You want to undo those in reverse. So the last thing that happened was the plus 5, so that's the first thing that we can undo. Subtract 5 on both sides. Those cancel. Now we have 3x on this side. 8 minus 5 is 3 here. And now we could divide both sides by 3. 3 divided by 3 cancels, and we get x equals 1. Let's plug that back in and check and see that it works. Plug a 1 back in here. 3 times 1 is 3, plus 5 is 8. Fantastic. Now, let me show you the other way you could do this problem that does work, but's not as good. So let me start here with 3x plus 5 equals 8. You could divide by 3 first. Now here's the problem. Tons and tons of kids will go divide by 3, divide by 3. And this is wrong, and here's why. The golden rule says you have to do whatever operation you're doing to the entire side. Now this entire side includes a 3x and a 5. So if you want to divide everything by 3, that's okay to do it first, but you have to divide everything on this side by 3. In this case, the 3's will cancel. You'll get x plus 5/3 equals 8/3. And that's mathematically correct and just fine, but I hope you see that it's a lot less simple than doing it this way. So now we have to subtract a fraction, 5/3, from both sides. Cancel, cancel. X equals 8/3 minus 5/3 is 3/3, which of course equals 1. So we do get the right answer, but I would really, really emphasize that if you work in reverse PEMDAS, figure out what things are happening, multiplying by 3, adding 5, what order they would normally be done in, and then undo them in the opposite order. Okay, let's do another example or two here. If you have parentheses and anything that can be simplified, it's best to simplify before you start solving. So to simplify, you just zoom in on one side and you follow PEMDAS. We are not solving an equation, we're just simplifying this. So 5 minus 2 is 3. 3 times 3 is 9. So on this side we have a 9. That's simplifying an expression, just zooming in on the right hand side. How about over here? Let's simplify this expression. If I distribute the -2, I get -2x Negative 2 times 5 is negative 10 and plus 2. So before I've started solving, I've simplified both sides. And now when I'm solving, it's going to be a lot easier. Let's put these two together. Negative 2x. Negative 10 plus 2 is negative 8. So I'm just combining those together. Now, again, let's look at what's happening. The x is being multiplied by the negative 2, and then it's subtracting 8. So to undo, we're going to add first. So typically you'll always add or subtract any loose bits first. Cancel those out. 9 plus 8 is 17. And now the x part can be divided by negative 2. Divide by negative 2. X equals 17 over negative 2. You could write this as negative 17 halves, or if you prefer as a decimal, what's that going to be? Negative 8.5. And you can plug this back in over here just to check and make sure it works. But in the interest of time, I'll move on. Alright, last example. Here we've got a variable, x minus 3, in the denominator in parentheses. So if we want to get x by itself, this is a lot trickier. X is in the denominator, and we typically don't want our variable in the denominator. We want to solve for it, isolate it by itself in the numerator. So the way to cancel, or not to cancel, but to get this x into the numerator is to multiply both sides by this part that has a variable. So we're going to multiply both sides of the equation by x minus 3. This side by x minus 3, and I like to put parentheses here. So when we multiply both sides, put parentheses around it. We multiply this side also by x minus 3. Okay, so on the left-hand side, we have an x minus 3 in the top and an x minus 3 in the bottom. Those cancel. So you're not actually going to distribute the 5 in, because this is canceling out the x minus 3 that was in the denominator. That's why we put it there in the numerator. So we have 5 on this side. Over here, though, we will distribute 10x. 10 times negative 3 is negative 30. Now we can solve like normal, just like the previous problems. Add or subtract to cancel this 30 out. We're going to add. Plus 30, so we have 35 equals 10x. Last step, divide by 10, divide by 10, and x equals 3.5. Okay, so the keys here, 2 or 3 of them. Number 1, do PEMDAS in reverse when you're solving an equation. Key number 2, simplify the sides of an equation, the two expressions on the left and right hand side. Simplify those first at the beginning, if possible. And the last thing is, always remember you can plug your answer back in and check and see if it works. Alright, that's good enough for now. I'll see you in class.